Hey guys, um, we did the first example in 7.3 in your homework on estimating proportion value of p in a binomial distribution. Um, I'm going to pan down to number two, do number two with SALT. So number one, you've seen how to do it by hand in the regular calculator. Number two, we're going to do it with SALT. What I recommend is paying close attention to the values given in this first sentence. R is going to be 291, N is 512. So 291 out of 512. I'm going to open up SALT. We're going to go to inferential statistics. One sample proportion, and I've already forgotten my numbers. 291 out of 512. 291 out of 512. Whoop, I put them in backwards, sorry. It's been a long day, but it's all good. Select confidence interval and generate results. Let's make sure it's 95%. Nope, 99%. So I need to change this to 99. Generate. Here's our proportion estimate, p hat. It's our point estimate for our sample. I'm going to copy and paste. Make sure we round to 4 decimal places. So that 3 becomes a 4. Lower limit, that's kind of hidden up here in the gray. 0.51. While the upper limit, and I'm only taking 2 decimal places, so 0.62. There we go. We are 99% confident that the true proportion of judges who are introverts fall within, that first one's a decoy, this interval. Part C, do you think the conditions n times p and n times q are greater than 5? N is 512, so if we take 512 times 0.568, you get 290, well over 5. 1 minus p, 1 minus 0.5684 is 0.4316. Now that's Q hat, that's the estimate for failure. Multiply that by 512, and you get 221. So we are well above 5 for both of those calculations. The conditions are satisfied, and so our estimate is approximately normal. All right, so that's very quick on SALT. 291 out of 512. 291 out of 512. Confidence interval, be sure to put the correct percentage in. Generate results. Your confidence interval is made up of these two numbers. Point estimate is this one. And let me also mention, if you're asked for margin of error, it's upper limit minus lower limit divided by 2. We weren't asked for the estimate, or excuse me, the error on this one, and so that's okay. While I'm here, I'm going to go ahead and pull up number 3 and do it on the calculator. And this way you have an example by hand, an example using SALT, and one using the graphing calculator. Stat tests, we're going to be looking for one proportion Z interval. That's it. It's the 11th option. X out of n, that's where you get your 362 out of 584. 362 out of 584. Then we're going to put in our confidence level, 95%. That's 0.95. Calculate. All right. The lower limit, and be careful around the 3 decimal places, is 0.580. The upper limit is 0.659. 659. Part A, the p hat. That is given right here. P hat is point, how many places? Round to 4. So this is 0.6199. Okay, we're 95% confident, or excuse me, 95% of all confidence intervals would include the true proportion of, I don't know what that is, potsherds? Potsherds? Probably should have looked that up in the first place. NP, if we take 584 times 0.62, that's well over 5. And if we take 584 times 0.38 or 39, we're still going to be well over 5. So the conditions are met, and we're good to go. Now we're good to go. What's the difference in that? Oh, the interval would include it. There we go. Always have to goof one up a little bit. It wouldn't be a good video without it. Thank you, and feel free to use SALT on all 3 of these. If you prefer the SALT method, if you want to use your calculator, fine. Either one is just as good. As long as you feel confident when you do your work, that's the main thing.